So I was having a rifle through my box of reamers, and as it happens I do have a 12mm reamer. So yeah, that decides it. I'm going to put a 12mm hole for the barrel nut. So I've discovered a gap in my drill collection. I have every drill between 1mm and 10mm in 0.1 increments, every single one. Then I go 10.5, 11, and a big gap between 11 and 12. I've got a 12.2, a 12.5, obviously a ½ inch, a 12.7, and various imperial ones larger than that. But I have nothing at all between 11 and 12mm. And I didn't want to put the reamer through an 11mm hole. I mean, that's just ridiculous, taking too much, taking a mil out with a 12mm reamer. So what I've done is used a milling cutter and just plunged it straight through to open it to 12mm. Now I'm not worried about the exact size of that because I can make the nut to suit whatever hole came out. So we have our 12mm hole through here. It actually came out at about 12.15, but obviously I'll make the barrel nut that fits in there to suit. Now I'm going to want a hole down through here to clear the M8 thread that's going to pull the two jaws together. So I picked up the centre line this way, the same centre here, and I'm going to put a 10mm hole right down through the bore where the barrel nut is going to sit. Now, because this is going to pivot like this, I may need to slot the 10mm hole out one way or this way on the top and the opposite way on the bottom, but that's going to be a fitting process, basically filed when I come to the point to fit it all together. So we're going to put a 10mm hole down in there, and that will allow a mil of offset before we go anywhere at all. Oh dear, I've been thinking again. In my original plan, I offset the centres where the two wheels sit so that the wheels will stick out a couple of mil. And that would allow me to get down to a knurl size. I mean, these do sit, 3 or 4 mil apart, of about, yeah, a 6mm, quarter of an inch, that sort of area. But more often than not, I'm doing larger knurls than that, ½ inch to maybe an inch. So if I actually reverse the way that these are going to fit together, they will go back into the holder, the holder here. They will go in the other way round. They'll be able to go in both ways, but more often than not, I'm going to be machining this way round. That puts the wheels further apart, and there's going to be less angle between the two jaws for the clamping pin, less rotational angle when I'm doing larger diameters. Of course, the only drawback of this is that the underside here, the wheel won't stick out from the underside. So what I've decided to do is I'm going to machine an angle from the centre of the slot, that sort of idea, on the pair of them, excuse my rough drawing, which will allow the wheels to stick out and it not to foul the part. So I think that's going to be my next procedure, is to put that angle on. And then of course I'm going to have to drill a hole down through this one for the draw bolt or what have you, but we'll come to that at the next stage. So I set the top up square to a scribe line, and I've actually measured it at 65.8 degrees with my new angle measuring device, should we call it. I then took the device away, remeasured what it was, and it came up with the same reading, 65.8 degrees. So I think I'm on my final cut here, and I've taken 7.27 mil from first touch. If I do the same with the next one, at the same angle, they should theoretically match. And I think I need to take a tiny bit more off. So anyway, I'll bring you back when I've done this one, and then I'll set the other one up. Well, there we are, that's the two done, and as you can see, the intersection of the angle is right on the bottom of that slot. The shiny mark you can see on there is where I filed the corners over. So, angle gauge seems to be quite accurate. I took exactly the same amount off, I set them up at the angle, and took from first touch 7.5 mil, and they in total, and they've both come out right smack on that end. So I don't think the angle gauge is too bad at all. Anyway, Bit awkward to use because it's a bit big and chunky, but happy so far. So while I'm at it, I decided to set the block up at 45 degrees and I'm fly cutting some chamfers on. There's the block I've done earlier, and you can see 45 degree chamfers on 4 corners, and I'm going 0.75 millimeters deep with the chamfer from first touch. So basically creep up to the edge. The second I hear it kick, I can go 0.75 millimeters, and that's the chamfer done. So I'm rotating 90 degrees at a time, keeping it at 45 degrees, and just machining the chamfers on the 4 corners. So I got the new nuts, the new stainless nuts with the rotating built-in washers, and I'm going to give the new, obviously give this a clean, and give the new nuts a try. Let's see if they're any better than the old type. Well, there they are, all installed, and the quick answer to the question is, yeah, excellent. Pleased with those. Okay, so I've got a bit of bronze here to make the barrel nut. I'll just face the end. I got one shot of this, it's the only bit of bronze I got left. Set to 0. I'll just touch off first. I have to hand feed this. I haven't reconnected my my lead screw. Right, we'll have a little measure of that. We would. Here we are. I knew I'd find my caliber somewhere. .5, and the hole size I'm looking for 12.15. Okay, so I know I can take milliside off that, no problem. Brittle old stuff. I've got a new edge on my tip. Right. So that should give me 12.5. I was running a bit slow. I'll take another 0.1 aside. That should put me at about 12.3. I don't want a tight fit for this, but I don't want it wobbling about either. So where are we? That's measuring 12.1. Well, 12.15. It doesn't enter there. Let me double check myself. Ah, yeah. There's a few hundredths tight, I expect. I'm going to take the minimum I can take on the DRO. Yeah. Just saw the needle move. And I'm taking a couple of hundredths off. burr. Can throw you off sometimes if you've got a little burr from countersinking. Oh, it's just trying. I think a couple more hundredths and we've got the diameter. You can only just see the smoke coming off there. It's minute the amount I'm taking off here. I put half a line on my hand wheel, nothing showed up on the DRO. So yeah, we're talking down to, it goes just a smidge of two. It is just like the tiniest bit tight. I've got a bit more on the hand wheel, nothing shown on the DRO. Speed things up a bit. To say that's a scratch, well, not even a scratch that. I think we'll have it now. Well, I think we're there. I'm going to put a chamfer on that edge, and then I'm going to part it off. That'll do it. I'm going to put my parting tool off and part that off 19mm thick. So parting tool set up. I'm cutting it down fine. If I got 1/2 mil between the parting tool body and the chuck, that's about it. We'll just part this off. When we're done, we'll put it in the other way. I'll just clean it up. Off you pop it. Oh, I was hoping it would land in my hand then. Never mind. Right, there we go, there it is. Okay, so take that rough end out. I'm only tickling this and I'm not tightening the jaws up stupidly tight to mark the machine surface I just put on. I quite often find it's easier just to swap tool posts than to bugger about, and I still haven't got any tips for my carbide parting tool. So there's a scratch off there. 45-degree tool again. Back on. And we'll match the chamfer from the other side. There. So there's the basics of the barrel nut. All I need to do now is drill it through the centre sideways. So a little bit of setup to do. I've got my vise all back up and back up on the milling, you know, for milling. I just need to find that edge of the vise. So I've got the wobble pin up. edge finder, wobble pin, and there. I'll set a 0 on my DRO. I'll just double check it. Back again. Right, I've got 0.5 to go on the DRO. Let's have a look. That says 0.2 on the DRO. That says 0. Yeah, there you go. So I now know. Let me just pull that out of the way. 2.5 ball. So if I go back another 1.25 mil. And I'll set a 0. There, 1.25 mil on the DRO. So the centre of rotation is dead in line with that vice jaw. I've scribed a line vertically on the barrel nut. Let's see, can I get in any closer without going all out of diddly-do? Here we are. This way's not critical because it can move back and forth 0.5 mil without sticking out the side of the knurler, so I'm not worried height-wise, but I do want to be in the centre this way, left and right as you look at it, when I drill through. And I've decided to go for M6 as the clamping bolt to clamp the two knurls together. I can always open it up to M8 later, but I can't go back to M6 if I put M8 on it. So I'm going to put M6 hole in it. So I'm going to set it up now. Just snip the vise. My pin's wobbling about a bit there. Let me just screw it up a touch. That's better. Yeah, I've got to come up just a tiny bit. There. Okay. And I'll lock the vise off there. So we'll have that wobble pin out of it. So I'm now fixed for height wise this way, and I need to index across the correct distance, half the pin from my 0 point, which is that edge. So the pin is 12.1, so I need to go 6.05. Which is, let me just come back out the way. Am I out of shot? I don't know. There, 6.05. And I'll just get my Allen key and lock my carriage off there. Now I've got a couple of parallels in behind this brass bar, or bronze bar I should say, but they are loose in there, and I think I should be able to just about, can you see them? Yeah, you can see them. Yeah, I can get them out. That's handy. Okay, so now it's ready for drilling and tapping M6, simple as that. So centre drill first. You're going a bit faster than that. Nice big centre drill in here. Want it to be bigger than the tapping drill on its diameter. Here's a good question. What size is that centre drill across its body? 6.2. I think I'm going to go right up to the top of the taper. That'll do. Oh. So, swap over 4. I think I've got a 4.5mm drill here. We'll pop in through first, and then I'll put the 5mm through afterwards. Just take it gently, break it through, because I'm breaking through onto a radius. Gently does it. Oh. There we go. And then in with a 5mm tapping drill for M6. Let me just make sure you can see that. Yep. Okay, gently just breaking through the back edge. Happy days. And I think what I'll do is hand tap through there with the M6 in the chuck and hand tap it through. I wonder if I could be brave and try and power tap that. Nah. Not feeling that brave today. Anyway, I'll finish off tapping that. And then we need to put a little countersink on the back side. So that's it, tap through. I've used a countersink a bit. And as you see, it gives you an elliptical shape. I'm just run a stone over the edges there, and I've done the other side as well, and we'll give it a whirl. I did have to polish the outside a bit, it threw up a bit of a burr where the holes go in, but yeah, a little bit of 240 grit. I've drawn a little line on the side so you can see the barrel nut rotate, and as you can see with the M6 thread, the barrel nut rotates, which allows for the differences as the jaws open and close. I may have to elongate this hole a little on the top. We'll find that out at a later date. Well, here we are. That concludes another episode, episode 7 of the Knurling tool. Thanks for watching, guys. Thanks for subscribing. Thanks for all your comments, and we'll see you all very soon. Cheers now.